Hello. This is going to be our concept map for unit for chapter 8. And I am going to just do one concept map instead of two. So I believe I'm going to cover the one that's on unit 8.2, which is on estimating population means, and allow you to work through the other section, which is on population. So I'm going to do the population, the proportion. I'm going to do the mean part and allow you to do the proportion part. Okay, so yeah, section 8.2, and it is on estimating population means. Okay, so I'm going to do a little flow chart here with you. So let's say that we want to estimate a population mean. Okay, so we want to find out something about a population. So where do we start? Well, it's easy. We are going to start by doing a sample. Okay, we're going to start by doing a sample. Let's see if my pen is active here. And okay, so the first thing I'm going to do to estimate my population mean is I'm going to use a sample. I'm going to go out and I'm going to ask a sample of people. And one of the key things about doing a sample, by the way, is how big is my sample size. So we're going to say, in general, we use the letter N to designate what the sample size is. So if we talk to 100 people, then N is 100. If we talk to 1,000 people, then N is 1,000. We talk to these people and we take that data, okay, and we're going to calculate, just throw it into our calculator, or however we're going to do it. Whoa, I'm going to spell that better. We're going to calculate two things. We're going to calculate the mean, and I'm going to call the mean X bar, and the standard deviation, and I'm going to call that S. Okay. So this is the standard deviation of my sample and the mean of my sample. Okay. And I'm going to take that and I'm going to find, there's some error involved. Okay. So I'm going to find my measure of margin of error. My margin of error. And I'm going to call my margin of error, just like I called the sample size N, I'm going to call it E. Okay. E. And E is really easy to figure out. E is going to be equal to 2 times the standard deviation over the square root of N. If you ever take a more advanced class in statistics, you're going to see that this 2 measure is really arbitrary. It's talking about 2 standard deviations, and really it should be 1.96, but in this textbook, we're going to say that's fine. Okay, we're going to say that is our margin of error. Okay, so again, we did a sample, we calculated our mean and our standard deviation, just putting in our calculator, L1, one frequency information, and we get this stuff. Now, once we get the standard error, let's talk about what we're really doing here. Okay, what I'm really doing is, remember, I want to know what the mean is. Okay, but the only thing I know so far is I know what my mean is for my sample, the 100 people that I talked to. And I can use this to calculate this margin of error. And what that's going to give me is a range. Okay, I'm going to get this range of numbers. I'm going to get this stuff right here, okay, where this is going to be X bar minus E, okay, and this is going to be X bar plus E. So using my sample, I can get this range. And I would like to say, I'm hoping that my population mean is going to live here. Okay, I'm hoping that it's going to live here. And by calculating the margin of error, I know that I am 95% confident that the population mean, mu, that mu lives inside of this range. Okay, I'm 95% confident. That 95% confident is because I chose a 2 here, okay, or 2 standard deviations. So that's very powerful, right? So I did a sample, calculated its mean and standard deviation, came up with a margin of error, which is between 2 values. And now I can say with confidence, 95% confidence, that the mean, the true population mean lives there. Okay, that is the gist of this unit. There's only one more thing I'm going to add, okay, and you can do it on a separate page if you need to. Oh, by the way, let me go back. If you want to do this, there is a way to do it using technology. That's always a cool thing, right? Technology is always a cool thing. And so what you can do is you can use your calculator, and let's see if I can't move this up a little bit. I'll put it on the next page then. So you can use your calculator to find that. And whenever we can use technology to make life easier, we want to. So you can go to our calculator, and we're going to go to the Stat button, and a place maybe we haven't been to yet. You're going to tab over to where you see it says Test. And under the Test tab, you're going to look for a thing that says Z interval. And if you put all of the data that you just had, I believe you put in your X, which is not your X bar, your N, and it will, I can't remember what the other parameters are, but you'll see when you get there, it'll actually give you the confidence interval. And I believe there's videos out there that take you through this exact process here. So just to say that there it is. And if you need to, if you need to see more on this, sorry, lost my train of thought for a second. Page 290 in your textbook is going to go through this as well. So don't forget to read your textbook, and those technology tips are there. Okay. So again, the end of this chapter, there's something very important. Okay. And the important thing, I guess I keep saying everything is important, but I guess it is. So think about what we just talked about. We took our sample and we talked about using it to come up with an interval. We call this a confidence interval of where we're fairly sure the mu lives. We're 95% sure that the mu lives there. The population mean lives there. So it looks like the sample is driving this. And in fact, it's the sample size. The size of the sample is really a big part of. Remember, our confidence interval was 2s over the square root of n. Okay, so notice that it's the n that's a big part of finding the E. So the reverse of that is true. Let's say that it's very important to me that I control the margin of error. I want to control the margin of error. So to do that, That's a car. What drives the margin of error is the sample size, okay? So the sample size drives the margin of error. So sometimes what I want to do is I want to say, well, what sample size is going to give me the margin of error I want? And so the second part of your chapter talks about that, and it gives you this sort of, you solve this formula for n. You'll find out n is equal to, that's an n is equal to 2 sigma over the margin of error, the quantity squared. And what that is saying is that if I have a certain margin of error that I need to have, I can tell myself, well, Victoria, you need to have a sample size of this size. And feel perfectly confident if you don't know, and you probably don't, know the standard deviation of the population, you can replace this with S, the standard deviation of the sample. That is it. I'm going to close this off because my phone is ringing, and I will post this up.